Okay class, so before we go to the Stokes theorems, I would like you to try one more exercise for the divergence theorem. Okay, the divergence theorem. So I want you to refer to exercise 4J. Okay, exercise 4J, page 181. So I want you to try question 4a. Okay, question 4a. So in this question, you have to use the Gauss theorem or the divergence theorem to evaluate this thing. Okay, this is the surface integral of a vector field that we have tried it there in class. Okay, so now you have to use the divergence theorem to solve it. It means you have to use the triple integral. Okay, triple integral. Then you have a divergence of vector f and dv behind, and you have a structure G. So here you have to use this formula in order to solve for this. Okay, surface integral. Okay, so let's look at the force given by the question. So the question says the force is equals to 3xi plus 4yj plus 7z square k. Okay, and the surface cover G with outward vector n. Okay, so the n is actually the outward. Okay, given G is a solid bounded by the surface, so you need to find what is G, what is the solid. Solid is bounded by surface z equals to 4x squared plus 4y squared, and plane z equals to n. So before you perform this one, you have to sketch what is this structure. Okay, so by referring to this formula, this is actually a function, a function for the cone. Okay, for the cone. So you can try to replace when the z is 0, what will happen to this formula. Okay, and by replacing the y or x to be 0, you can know whether the line is a curve or a straight line. So by replacing one of it to be 0, so the curve, it will be a straight line. Okay, after you square root it, because the x has power 1. So this one is actually the cone. So you need to draw the structure of the cone. Okay, so let's draw the structure of the cone. Okay, in our 3D coordinate system. So when you have cone, maybe something like this, we have a straight line connecting. Yeah. Okay. And we have a straight line connecting. Okay, this is how you draw your cone. Okay, and it says that the plane is until z equals to 8. So here will be 8. So actually the height of the cone can be extend to infinity, but here it mentioned that the 3D structure is covered by this function and also plane z equals to 8. So you will get this structure. So now you have to solve this one. Triple integrals, and then you have a divergence of f, and then you have dv. Okay, first of all, let's settle this one, the divergence of f. Okay, the divergence of f is equals to, you perform the partial differentiation for each of the I, j, k component. Okay, please don't forget what is the meaning of the del. Okay, so the del is actually equals to this one. Okay, and dot product with the f given by the question, which is 3xi plus 4yj plus 7z squared k. Okay, so you multiply the I component with the I component. So this one you will get 3, okay, plus the 4 and plus the 14. Okay, so let's try to substitute it into the triple integral. This is 7 plus 14 z dv. So now you have to choose the suitable dv for you to solve this triple integral. So you can refer to a structure. You can use the cylindrical coordinate. It means your dv will become dz r dr d theta. Okay, so now you have to set the range for the r, for the z and r and theta. So z, okay, z. So you have to assume yourself inside the solid. Okay, so when you refer down, you actually see the cone. Okay, and when you refer up, you see a flat surface which at z equals to a. Okay, so your z will be from the equation of the cone, 4x squared plus 4y squared, and then square root, okay, to 8. Okay, the height. Okay, next will be your r. Okay, your r will be the radius of the circle. So you have to refer when you view your cone at top. Okay, so you will see this circle. So this circle, you have to find out the radius. So how to find out the radius? So this is the formula for the cone. So when at height equals to 8, so you will have a radius of, you have to simplify your equation. So this one becomes 64, this one becomes 4x squared plus y squared. Okay, so this one becomes 16 equals to x squared plus y squared. So your circle will have a radius of 4. So your r will be ranging from 0 to 4. Okay, and as for your theta, it is a complete circle. So your radius will be from 0 to 2 pi. So you substitute it into your triple integral, 0 to pi, okay, 0, 4, and then just now it is from 4x squared plus 4y squared, right? And this one is 8. So this one becomes 7 plus 14 z. Okay, you have the dz, you have the r, dr, d theta. Okay, so this thing you have to change it to variable r. So it will become, I will change it right here. So it will become 2r here. Okay, so you perform the triple integral. Okay, so this one you will get 7z plus 14 z squared over 2. So you have 8 here, 2r here, and you have r, dr, d theta. Okay, so this one will become 2 pi 0, 4. This one become 56. Okay, plus this one is 7. Is okay, 64 times 7, 448. Okay, so and then minus with 14r plus 28r squared. And you have r dr d theta. So you simplify your things. So 56 plus 448, you have 504 minus 14r minus 28r squared. Okay, and r here. Okay, you can press calculator for answer. So this one will be 504 minus 14r minus 28r square. Okay, then you have to put the bracket. Multiply with the r. And then from 0 to 4. So the answer is 5824 over 3 d theta. And when you multiply 2, it becomes 11648 over 3 pi. Okay, so this is your answer, same as the answer from the module. Okay, so this is how you solve the how you use the divergence theorem or the Gauss theorem in order to solve the surface integral of a vector field.